Okay, the journey continues. We're hitting sections C and D today. Before we begin, however, just a quick review from one of the main points from the previous video. We've got the unit circle, so it's got a radius of exactly 1. Any point along the unit circle, we found that its coordinates, instead of being thought of as x and y, could be thought of as the cosine of theta, where theta is the angle of rotation, comma, the sine of theta. We also saw that the equation for the circle itself was x squared plus y squared equals 1, and that comes from the Pythagorean theorem, since the x coordinate squared plus the y coordinate squared has to equal the radius squared, and the radius we said was 1, so yeah, x squared plus y squared equals 1. Now this is going to lead us to our next major identity. We saw a few identities at the end of the last video. Identities are just facts that are true about any angle theta, and we can use them to quickly work out sine or cosine values of other angles. So here's our next big one. Since we know that x squared plus y squared is equal to 1, and since we know that the x value is cosine of theta and the y value is sine of theta, that means that cosine squared of theta plus sine squared of theta equals 1. This is pretty neat because it means that you can take any angle that you want, take the sine of it, square that value, then take the cosine of it, square that value, add the two together, and you're going to get 1. Now obviously we need to be careful about rounding here. These decimals are all going on forever. They're irrational. So if you rounded this decimal before squaring it, then your final answer would be close to 1. It wouldn't be exactly 1. But if you do not round at all, then your answer will be exactly 1, no matter what angle you started off with. And I think that's pretty cool. You don't need to work out what the sine and the cosine of the angle are separately before squaring them, but you do need to be careful about it when you do it. For example, this is not the correct way to type it in because here I'm actually squaring the angle, 37.9. So I'm getting some gigantic number, and then I'm taking the sine of that. That's not what we wanted to do. Instead, we wanted to take the square and put it outside of the brackets. And there we go. Here, it put parentheses automatically for me, but notice that if I just type it in and then put the square next to it, I don't see the extra brackets here, but actually when I press enter, it inserts them there for me. And second thing is that it helps us figure out the sine of an angle or the cosine of an angle if we know the other one. I'll show you what I mean. So say we're told that the sine of theta is equal to 3 over 4. And furthermore, another important piece of information, theta is in between 90 and 180 degrees. What does that mean that the cosine of theta is? All right, so first of all, if our angle is in between 90 and 180, that means that our angle is somewhere in the second quadrant. Now that's important because remember our ASTC, right? So in the first quadrant, all of our trig functions are going to be positive. In the second quadrant, only sine is. Now, we know from the problem that sine was positive, which meant that the angle had to be in either the first or second quadrants. But the reason that this is important is that when we're finding our value for cosine in a second, the answer has to be negative. And I know that in advance without having to do any other work, and that'll enable me to check my answer later on, make sure I don't make any foolish mistakes. Now, if I want to use the identity, I'm just going to set up an equation. Cosine squared plus sine squared equals 1. I happen to know that sine is equal to 3/4. I can square that. I can subtract it from 1. I can take the square root of both sides. And now cosine of theta has to be equal to plus or minus, since I'm taking the square root, plus or minus the square root of 7 over 4. Well, which one is it? Is it plus or minus? Well, we just said it's going to be minus. Some of you might prefer a geometric approach, however, so you don't need to use that identity. If we draw a right triangle, let's say this here is our angle theta. Now we were told that the sine of theta was equal to 3/4, so we know that sine is equal to opposite over hypotenuse. And now we just need to use the Pythagorean theorem to work out what this side over here should be. I think it's going to be the square root of 7. And then if we calculate the cosine of this angle, we will get the square root of 7 divided by 4. Same as we had in the last problem, except here it's a positive number because I'm dealing with a triangle and the lengths of the sides should be positive. So that's why it's important, again, to remember what quadrant we're in. Since we're in the second quadrant, we need to say that the cosine of that angle is going to be negative. Now you do have one other option here, which is to start off thinking geometrically with the right triangle and then jumping to your calculator. So if you know that the sine of this angle is equal to 3 over 4, we could of course figure out what that angle is by using inverse trigonometry. The problem with this is that when you do that, the calculator is going to give you an angle which is in the first quadrant. It's not giving you the angle in the second quadrant. So we would need to work out what the correct angle is. If you remember from the end of last video, we had an identity that said that the sine of 180 minus theta is equal to the sine of theta. So check this out. The sine of this angle is the same thing as the sine of 180 minus this angle. So really the angle in this question is 180 minus 48 point, whatever number that is. So this is the angle that we're dealing with, and then we'd have to find the cosine of that, and that'll give us a decimal approximation for the negative square root of 7 over 4. As you can see, I think doing it that way is unnecessarily complicated. All right, so now we're about to jump into section D. Before we do, I want to remind you again, in the last video, we saw that using the unit circle, we are now able to work out the sine and the cosine values for a whole bunch of angles. And we can do this just from memory or by thinking about the circle just for a few seconds. So in the examples that we looked at were 0 degrees, 90 degrees, 180 degrees, and 270 degrees. Since the x-coordinate of the point on the unit circle is the cosine of the angle, and the y-coordinate is the sine of the angle of rotation, this enables us to figure out what the cosine and sine of certain angles are just by thinking about what the coordinates must be. So for example, say we were at over here, we've rotated 0 degrees. Well, the cosine of 0 has to be the x-coordinate. Cosine of 0 is 1. The sine of 0 is equal to 0. If we rotated 90 degrees, so we're here, the cosine of 90 is equal to 0. The sine of 90 is equal to 1. If we rotated 180 degrees, cosine of 180 is negative 1, sine of 180 is 0, cosine of 270 is 0, sine of 270 is negative 1. These values should all be memorized. If you eventually make it into an IB analysis course or an AP calculus course, you are expected to have these values memorized. You should not need a calculator for them. You should not need to check your notes. You should have all of these in your head. So start memorizing them right now. And this next section is about memorizing even more trigonometric values of specific angles. And we begin with 45 degrees. So you should know that the cosine of 45 degrees is equal to 1 divided by the square root of 2. And the sine of 45 degrees is also equal to 1 divided by the square root of 2. Here's why. If you think about the point on the unit circle at 45 degrees, we have not only a right triangle, but we have an isosceles right triangle. So that means that whatever this length is, the book is calling it A, we should have a squared plus a squared equals 1, and then we can solve that for a, and we get 1 divided by the square root of 2. By the way, this is often written as the square root of 2 divided by 2 if you rationalize the denominator. This is actually how I have it memorized rather than 1 over square root of 2. You should know one or both of these, however. And then the book's giving you a very poor decimal approximation. Really? Only one significant figure? That's ridiculous. Don't bother with this. That's a lot better. Still, I want you to remember the exact value, not the decimal approximation. All right? So 45 degrees, the cosine and the sine are both square root of 2 divided by 2. Here's the thing though. If you can memorize that one angle's sine and cosine, you get a whole bunch of other angles, sine and cosine, for almost free. So check this out. So here's our 45 degrees, and we've got our cosine and our sine. Now let's say we rotate into the second quadrant to 135 degrees. The key here is that 135 degrees is 180 minus 45. So the y value is going to be the exact same thing as 45 degrees, which means that the sine of 135 is also equal to 1 over root 2. The x-coordinate, well, here we're just reflecting over the y-axis. So the cosine of 135 is equal to negative 1 over the square root of 2. This should all look familiar from the last video where we saw, for example, that the sine of 180 minus theta was equal to the sine of theta. That's exactly what we're seeing right here, since 180 minus 45 equals 135. We can also rotate into the third quadrant and get 225 degrees. This is 180 plus 45 more. So this is just a reflection over the y and then a reflection over the x. So both the values are negative. And then if we go into the fourth quadrant, again, 45 degrees from the horizontal, that's going to get us 315, since we're just 45 degrees shy of 360. Now our cosine of that value, of that angle, is 1 over root 2. Our sine is negative 1 over root 2. Confirm again that our ASTC is all correct. All right, so now you should be able to work out the sine and the cosine of 45, 135, 225, 315. You should even be able to work out the sine and the cosine of 405 degrees, because yes, we can even have angles that are bigger than 360 degrees if we rotate all the way around. You should even be able to work out the sine and cosine of negative 45 degrees, of negative 135 degrees, and so on. You now know infinitely many angles, sine and cosine value, as long as they are multiples of 45 degrees. Now we're going to jump to multiples of 30 degrees. There's a proof on screen. It's a little bit more complicated than the last one. Good news, you don't need to know it. All you need to know is this right here. If we're dealing with, well, we're actually dealing with 60 degrees here. The cosine of 60 degrees is equal to 1/2. The sine of 60 degrees is equal to the square root of 3 over 2. And we're going to see on the next screen how this is really going to help us. But first, let's just think about this geometry for a second. If we're rotating 60 degrees, then what kind of a triangle do we have now? This is a radius. This is a radius. That makes this an isosceles triangle, but since this is 60 degrees, it's actually an equilateral triangle. I don't know what this height is, but I do know that it's going to perpendicularly bisect this side. So that makes this distance right here equal to exactly 1/2. Now, this right triangle, if we just look at half of it, we can use the Pythagorean theorem on that, and that's where this line's coming from. And then from there, we're solving for k, and then we get the height of that. And then since we're dealing with 60 degrees, the cosine of 60 will be 1/2 over 1, and the sine of 60 will be square root of 3 over 2 over 1. Now, look at all the angles this gets us. So we start off right here with 30 degrees. Okay, this needs to be memorized. The cosine of 30 degrees is equal to the square root of 3 over 2. The sine of 30 degrees is equal to 1/2. When we go to 60 degrees, they swap. And by the way, we saw identities at the end of last video that said that the cosine of 90 minus theta is equal to sine of theta, sine of 90 minus theta is equal to cosine of theta. So if you set theta equal to, say, 30 degrees, then you get cosine of 60 equals sine of 30. and sine of 60 equals cosine of 30, and that's exactly what we see here. You could also get that from considering a right triangle. If this were our angle theta, whatever its sine is, let's just call it x over h, the sine of this angle has to be the same as the cosine of this angle over here. But since this is a right triangle, this angle has to be 90 minus theta. And you can swap that around to get the other identity as well. Anyway, so now we've got 30 and 60. Now we can think just as we did before, just thinking in terms of reflections. And now we can figure out angles in the other quadrants. So remember, this angle here was 30 degrees. So if we travel 30 degrees above the horizontal from over here, what angle will that get us? That'll get us 150 degrees. So the cosine of 150 degrees should be the same as the cosine of 30, except the opposite sign. And the sine of 150 degrees will be the exact same as the sine of 30 degrees. Likewise, we can work out 120 degrees, because 120 is, again, 60 degrees above the horizontal. And this, by the way, is really how I think is the easiest way to memorize all this stuff. Always consider angles as being rotations above or below the horizontal axis, and that will tell you which reference angle in the first quadrant you want to think about. So for example, down here in the third quadrant, if I was interested in 210 degrees, I just have to think, well, that's 30 degrees more than 180. So I want to think about 30 degrees. The cosine of 30 was root 3 over 2. The cosine of 210 is going to be negative root 3 over 2, because I'm in the third quadrant and cosine is negative. And then the sine also is going to be the same as for 30, but also negative. So we've got 210, we've got 240, we've got, from this horizontal, 360 minus 30, that gives us 330 and 300. Now, I'm not expecting you to memorize all of these angles and all of their sine and cosine values right away, but I do expect you to get there eventually. For the time being, it would probably help you to have a unit circle handy to reference as you're working through things. You could find these on a million websites out there. I'll also make one available on our class website so that you can look at it really quickly when you need to work out some exact values rather than using your calculator. You will, of course, use your calculator for sine and cosine values that are not multiples of 30 degrees or multiples of 45 degrees. But anytime we're dealing with those angles, we really want to use the exact sine and cosine values, so we do not want to use the calculator. And then we'll also get into the habit then of memorizing them instead of relying on technology for absolutely everything. Now, in this particular unit circle, you'll see that for all the important angles, we have the degree measurement, and then we have the coordinates, which should be interpreted as the cosine of that angle and then the sine of that angle. And I want you to focus, as you're looking through this, I mean, it's color-coded to help you out as well, but I want you to really focus on the reflections and finding the shortcuts. All right, and look to see the number patterns. Look to see where numbers are the same, look to see where the signs are changing, and keep in mind, of course, your ASTC. Finally, on this diagram, you're going to notice there's a couple of other numbers happening just inside the circumference of the circle. Those are the angle measurements in radians, that other unit of measuring angles that we've kind of referenced a few times, but we haven't really worked with. Don't worry, that's coming later on in this chapter. They will be very important, so you might as well get used to seeing them now. If you're having difficulty memorizing all those things, there is another trick that you might like, and I'll put some links in the video description so that you can read about this and see a video of someone doing it. But the idea is that if you take your left hand and then hold it out in front of your face, you can imagine that your thumb is the y-axis and your pinky is the x-axis. And then if we want to work out sine or cosine values of the special angles in the first quadrant, all we have to do is put that finger down and then do we see here? So say we're talking about 60 degrees. So our pinky's the x-axis, that's 0, and then if we go up, that's 30, 45, 60. So we're going to take that finger and put it down. And the rule is that the cosine of that angle is going to be the square root of the number of fingers above this one divided by 2. So how many fingers are above this one? Well, just 1. So we're going to take the square root of 1 divided by 2, and that gets us 1/2, and that is the cosine of 60 degrees. If we want the sine of 60 degrees, the rule is taking the square root of the number below that finger. How many are below it? 3. So the sine of 60 degrees is going to be the square root of 3 divided by 2. So that's kind of neat. Some students in the past I know have really enjoyed this trick. Not everybody uses it, but it's something for you to think about. Of course, it only works when you're in the first quadrant. If you're in any other quadrant, then you need to think. So if, for example, I wanted cosine of 300 degrees, I need to think, well, 300, that's in the fourth quadrant, and 300 is exactly 60 degrees less than 360, so 300 is the same as minus 60. I'm right here, so I'm thinking about 60 degrees. So I would do the exact same process as what we just did, except I know I'm in the fourth quadrant, so the cosine would still be positive, actually, so that's still going to be equal to 1/2, but the sine of 300 degrees, since we're in the fourth quadrant, that is now going to be negative. So anyway, I want you to give this a shot. Try to memorize as many of these as you can. Start to get used to them. Now, we haven't said anything about tangent yet, but recall from last video that tangent is equal to sine divided by cosine. And for me personally, that's all I bother memorizing. Since I know the sine and the cosine values, if I need to know the tangent of one of those angles, I just write out a fraction and simplify it. I can do that really, really fast. If you want to memorize these tangent values, you're certainly welcome to. I just don't think that there's a need for it because, as I said, you can just do some simple division, cancel some denominators, and then get a nice answer like that. If you want to rationalize the denominator, great, you can get that. Yes, if you can memorize all of them, sure. It's faster if you just have them all memorized. However, you already have the sine and cosine values memorized. You already have this identity memorized. Personally, I think that there's a limit to how much we can all memorize. So for me, I decided, no. I don't want to have these values memorized. I'll just work them out because it doesn't take that much time. Okay, can we just do a couple of examples here? We're going to find the sine and the cosine and the tangent for all 3 of these angles. We start with 60 degrees. You should have the sine and the cosine for 60 degrees memorized right away. Sine is root 3 over 2, cosine is 1/2. To work out the tangent of 60 degrees, we do root 3 over 2 divided by 1/2. The 2's cancel out, and that gets us root 3 over 1. Great. Second example, 150 degrees. 150 degrees is in the second quadrant, and it is 30 degrees above the horizontal. So I'm thinking in my head about 30 degrees. I know that the sine of 30 degrees is 1/2. So this is going to also be 1/2 since we're in the second quadrant. Sine is positive. I know that the cosine of 30 degrees is square root of 3 over 2. Since we're in the second quadrant, my answer for cosine is going to be negative square root of 3 over 2. To find the tangent, I do 1/2 divided by negative square root of 3 over 2. Again, the 2's cancel, and we have negative 1 over the square root of 3. Or if you want to rationalize the denominator, negative square root of 3 divided by 3. Finally, we go to 225 degrees. That's in the third quadrant, and I'm thinking about 45 degrees now because this is 45 degrees below the horizontal. The sine and the cosine of 45 degrees are both square root of 2 over 2. This is in the third quadrant. So in this case, the sine and the cosine will both be negative square root of 2 over 2, or negative 1 over the square root of 2 if you prefer. And for the tangent, Since I'm dividing this number by itself, the tangent value must be 1. The next thing we can do is we can use this to work out what an angle is if we know certain information about its sine and cosine. Now this might sound to you like it's just inverse trigonometry, and you might ask yourself, well, why don't we just use that? Well, the issue is, as we've just established, there are many angles now that will all have the same sine or cosine value. So for example, the sine of 30 degrees is the same as the sine of 150 degrees. And those are both equal to 1/2. But the thing is, if you ask your calculator what the inverse sine of 1/2 is, it's going to tell you 30 degrees. It's not going to say anything about 150, and it's not going to say anything about 390 degrees if you go all the way around the unit circle and then go another 30 degrees past that. It's only going to give you the one answer. So again, the calculator has its limitations. So here's how we're going to answer a question like this. We're told in this problem that the cosine is positive 1/2 and the sine is negative root 3 over 2. So right away, what quadrant are we in if cosine's positive and sine is negative? We're in the fourth quadrant. So here it says it's in between 0 and 360. Well, no, now I know it's in between 270 degrees and 360 degrees. Now I just need to figure out which angle it is. Well, if we know that the cosine is 1/2, well, what angle in the first quadrant has a cosine of 1/2? Well, that would be 60 degrees. Oh, by the way, the sine of 60 degrees is root 3 over 2. So now we just need to figure out what angle in the fourth quadrant would be the partner of 60 degrees. Well, it's going to be 60 degrees below the horizontal, which is going to be 360 minus 60. 300 degrees is the answer. That is where this video is going to end. Again, I want you to take a look at the unit circle and really focus on the geometry of it, focus on the reflections, look at the number patterns, maybe print it out. Tape it to the ceiling above your bed so when you're falling asleep at night you can stare up at it and have happy dreams about it. Do whatever you got to do to get good at this stuff, because trigonometry it's huge. As I said in the last video, it combines a ton of different areas of mathematics, and we're really still just getting into it. I know the book only has one more section in this chapter, but as I said last time, we're going to do a lot of extra stuff too. So get excited. I know that I am.